Welcome everyone to our mathematics series. We are continuing with our bearing SSCE aspect of it. This topic deals with measurement of points on the Earth's surface based on some principles. The resulting shapes from our bearing problems are mostly triangles, whose lengths and angle are used to solve for the unknown ones. This task, that is, of solving for the unknown angles and length, needs some prerequisite knowledge. Among these are elements of plane geometry as treated in the preceding unit, types of triangles and ways of finding the unknown angles and lengths, types of triangles. A review. The first one here is equilateral triangle. In equilateral triangle, the properties are all sides are equal, that is length A is equals to B and is equals to C. All angles are equal, that is angle A is equals to B is equals to C. Properties of isosceles triangle. Two sides are equal, that is B is equals to C. These angles are equal, which is B is equals to C. Please take note of how the angles and the sides are labeled. Where the angle A is facing is labeled the side small a. Where B is facing is labeled the side small b. Where C is facing, angle C is facing, is labeled the side small c. This is the pattern we follow. Take note of that. The next triangle is scalene triangle. Properties of scalene triangle. None of the sides are equal. That is, A is not equals to B and is not equals to C. None of the angles are equal. That is, angle A is not equals to angle B and is not equals to angle C. Next, we treat right angle triangle. Properties of a right angle triangle. The only unique feature of a right angle triangle is that one of the angle is 90 degrees. In this case, angle Q is 90 degrees. Next, we have acute angled triangle. Yes, properties of acute angle triangle. We have three angles are less than 90 degrees. That is, angle A is less than 90, angle B is less than 90, and angle C is less than 90. In a similar vein, properties of obtuse angle triangle. One of the angles, that is theta, is greater than 90 degrees, but less than 180 degrees. To find the unknown angles or lengths of the last two triangles, that is acute and obtuse angle triangles, lead to sine or cosine rule. The sine rule states that A over sine A is equals to B over sine B, which is equals to C over sine C. The notations ABC and angle ABC are as applied to the acute and obtuse angle triangles above. Conditions for applying sine rule. One length and all angles. 1. 2. Two sides and an angle opposite one of the given sides. 3. Two angles and one side opposite one of the given angles. Let's take some examples. QRS is a triangle with QS equals to 12 meters, and angle RQS equals to 30 degrees, and angle QRS equals to 45 degrees. Calculate the length RS. Solution based on our information given that the triangle is QRS with the length QS equals to 12 meters and our angle Q equals to 30 degrees, our angle R equals to 45 degrees. That's two angles and one side opposite one of the given angles condition is fulfilled. Hence, sine rule apply. RS over sine 30 will be equals to 25 degrees. From there, we make RS the subject formula. RS will be equals to 12 sine 30 all over sine 45 degrees, which is equals to 12 times half divided by 1 over root 2. When you simplify, it will give us 6 divided by 1 over root 2. And the result is 6 times root 2, which is equals to 6 root 2. Another example. Given that the two angles of a triangle are 30 degrees each, and the longest side is 10 centimeters. Calculate the length of each of the other sides. Solution. The third angle should be facing 120 degrees. That is facing the longest side. Since 30 plus 30 plus theta is equals to 180 degrees, raising sum of angles in a triangle. And from there, theta is equals to 120 degrees. Now we can sketch our triangle. From the diagram, all angles on one side, hence sine rule will apply. So we have 10 sine 120 will be equals to B sine 30. From here, B is equals to 10 sine 30 divided by sine 60. Since sine is positive in the second quadrant, the result will be 10 times half divided by root 3 over 2, which will give us 5 times 2 divided by root 3, which is equals to 10 root 3 divided by 3 centimeter. Another example. In an acute angle triangle PQR, with PQ equals to 10 meter and PR equals to 15 meter, angle PRQ equals to 40 degree, evaluate angle PQR. Solution. The required triangle is drawn below. From the triangle, we observe that two sides and one opposite angle. Thus, we can apply sine rule. 10 over sine 40 will be equals to 15 over sine Q. From here, making sine Q the subject formula, sine Q will be equals to 15 sine 40 divided by 10, which will be equals to 1.5 bracket open 0.6428. That is to say sine Q is equals to 0.9642. From here, Q will be equals to sine inverse of 0.9642, and that is equals to 74.62 degree. Next, we treat cosine rule. Cosine rule says that a square is equals to b square plus c square minus 2bc cos a. Take note, our notation are from the acute angle triangle and obtuse angle triangle. Also, b square is equals to a square plus c square minus 2ac cos b. Similarly, c square is equals to a square plus b square minus 2ab cos c. Please take note of how the cosine rule is arranged. If we are dealing with a square, then the cos will be a, and the other two items inside will be B and C. And if we are dealing with b square, then the cos will be b, and the other two items inside will be A and C, which are not mentioned there at the beginning. Then if you are dealing with c square, then the cos will deal with C, and the other two items there will be the other alphabet not mentioned, which is A and B. So with simple understanding, you don't need to do any cramming. Conditions for applying cosine rule. 1. Giving two sides and the included angle. 2. Giving all the three sides of the triangle. In this case, the above stated rule will have to be adjusted to make cos A or cos B or cos C the subject of the formula, as the case may be. Thus, we have cos A equals to b square plus c square minus a square divided by 2bc. Cos B will be equals to a square plus c square minus b square all over 2ac. Cos C will be equals to a square plus b square minus c square all over 2ab. Let's take some examples. Find the length xz in the triangle below. Solution. The condition, two sides and the included angle is in the given problem. Thus, cosine rule applies here. So we can conveniently say xz square is equals to 2 square plus 1 square minus 2 times 2 times 1 times cos 120, which is the same as 5 plus 4 cos 60. Since cosine is negative in the second quadrant, the result is 5 plus 4 times half, and that gives us 7. Thus, angle xz is equals to square root of 7. Another example. In triangle ABC below, find angle BAC. Solution. Three sides of a triangle, which means that we can apply the adjusted cosine rule to find the required angle. We say, and that is cos A will be equals to c square plus b square minus a square divided by 2 times c times b. And the result is, when we substitute for the given value from the triangle, we have cos A will be equals to 8 square plus c square minus 5 square divided by 2 times 8 times 6. And that will give us 64 plus 36 minus 25 divided by 96. And our result is that cos A will be equals to 0.7813. And from here, A will be equals to cos inverse of 0.7813, which is equals to 38.62 degree, approximately equals to 38.6 degree. Another example, two sides of a triangle measuring 10 cm and 50 cm enclosed in an angle of 55 degrees. One, calculate the third side, and two, find the two other angles. Solution. The required diagram is as shown below. First, we solve question 1. Since we have two sides and an included angle, we apply cosine rule to find b. Thus, b squared will be equals to 10 squared plus 15 squared minus 2 times 10 times 15 cos 55 degree, which is equals to 100 plus 225 minus 172.07 degree. The result is 100 plus 225 minus 172.07. And that it follows that b squared is equals to 152.93. Thus, b will be equals to square root of 152.93 degrees. It follows that b is equals to the square root of 152.93, and that is equals to 12.37 centimeters. Applying sine rule to find a, that's 2. We have that 12.37 divided by sine 55 will be equals to 15 over sine a. From here, we have that 12.37 times sine a will be equals to 15 sine 55. And making sine a the subject formula, sine a will be equals to 15 sine 55 divided by 12.37. And sine a will be equals to 0.9933. Thus, a will be equals to sine inverse of 0.9933, which is equals to 83.36 degrees. Applying sine rule to find c, we have 12.37 divided by sine 55 will be equals to 10 divided by sine c. The cross multiplier, we have 12.37 sine c will be equals to 10 sine 55. And making sine c the subject formula will be equals to 10 sine 55 divided by 12.37, which will give us 0.6622. Thus, c will be equals to sine inverse of 0.6622, which is equals to 41.47 degrees. We've come to the end of the example under this subtopic. Next, we have some exercises, which I will advise strongly that you try and enhance on them. Our teachings today were taken from the hidden fact in new SSCE Mathematics 223 up to page 226. The teaching are available in the hard copy of the book, which are in any bookshop close to you, or you can get them from the soft copy of our book with the website given at the bottom of the screen. Thank you.